curve and the integrals. But so we're gonna start with a definite integral. With the situation here, what we're gonna do is we're gonna give you tell you what does definite integral mean. So if you have a definite integral, it should look like something like this. Integration between a to b of f of x dx. So usually we want to teach you arithmetic first. But today I'm going to teach you a little bit different. I'm going to start with geometric understanding before we do an arithmetic. We're going to talk about how do we calculate this next week arithmetically. But right now we start with geometric understanding. So for example, this is known as the lower bound. This is the upper bound. Now, next week, we're going to learn that this is equal to f of b minus f of a over b, f of b minus f of a. But right now, this just means the area under the curve which is between the function and the x-axis. Now, if it's the function's below x-axis, then your value will get negative, right? It will get negative. We're going to talk about that later today, but right now we're just focused on the graph is above x-axis. So the boundary is going to starting x value to the nx value. So what I'm trying to say is, if I have integral of, let's just say this is a f of x, and that's a to b. If you integral f of x from a to b of dx, this equal to this area. Okay, that will be the value of this area, the units of this area. Now, if the graph is below x-axis, then you will get negative value, especially from the low bound to high bound. Now, usually, I will prefer this number to be more negative. And this is a preferred to be more positive. Why? Because if you, this is one, usually if this is, it should start with a lower value to a higher value. Okay, it should start from lower value to higher value. If it's the other way around, we have to use the other property. Is this okay? Okay. So what do you think integration of 4 dx between 2 to 5? So what does this mean? First, understanding the geometrically. Everybody can understand this. It's not a very difficult situation. Now, put in mind, some of you guys know how to take a definite integral, which is fb minus f of a. But right now, we don't know anything. Right now, we just say, hey, how do we look at geometrically? What does a 4 look like? Okay. So I'm going to ask some of you guys and tell me what a 4 look like. I know, Amelia, no. Josephine, what do you think a 4 look like? Cameron, what do you think?
Oh, so I don't really understand what you mean.
Okay. Alex?
Don't even know what question you asked.
You kind of zone out. Neha? You are pretty close. It's not a square though. Kim? It's a slope. I don't think that's a slope. No. Stefano?
Is it the height of the rectangle?
Okay, so here's what I'm trying to ask. What is 4 representing graphically? Like, what does a 4 represent graphically? I'm not saying you're right or wrong. I'm just saying, what's a 4 graph look like? So remember, this is a functions, right? So if a function is 4, what does that look like? Straight line. Is that vertical line or horizontal line? Horizontal line? Okay. Did Amelia help you? Okay. So it just means y equal to 4. Because this is a function, right? Function is equal to y, right? So y is equal to 4. Is that okay? So what will be the area between, let's say, 2 to 5? I mean, shit, I can't count. So 2 will be the area under the curve. Yeah, Cameron? 12. I know you know, Amelia. I'm going to ask you hard questions. Easy questions, no fun. So that's equal to 12. Geometrically, it's really easy. Just count up the square. 3 times 4. You see the difference of here is 3. And this is 4. So it's going to be 3 times 4 is a rectangle. Okay. Now using the same logic. Completely different problem, but the same logic. I want you to figure out geometrically understanding between that says 1, 2, 4 of 3x plus 2. And also, Aiden, after you finish this, you gotta show me what's the rotation look like. For the same logic, do you know its integration from 1 to 4, 3x plus 2 dx? Cameron, you got it? Okay. What'd you get? 57. Pretty good. So how did Cameron come up with that number? Do you know? I know he knows, but I don't know. How did he come up with the 57/2? It's very specific. How did he come up with it? No, not yet. I'll ask you in a second if nobody knows. Oh, I have that joke.
Let's go to chickens. Rolling chickens. No, not even chickens.
Oh, really? How do you know the duck?
It's still, the neck is still long.
Oh.
You can see the opening up.
See, what I like, I think they should replace the C with the egg.
Yeah.
Because, you know, you can have, but you cannot have negative egg. So that is, yeah, but what, how do you, no, how do you do like C, like plus C? So I was thinking about C should be egg. But you cannot have a negative egg.
Yeah.
Huh?
You just get one less chicken.
How do you have a negative egg?
You have to.
Huh?
You have to give it one.
Okay, so you owe people egg. Chicken, you owe me egg. All right. How many of you guys know how did he get 57/2? Two people? Okay, what happened to the rest of you guys? Okay, the reason why I want to go over this is something. What kind of shape is this, Father? Yeah. Thank you, Cameron. At least Cameron is good at geometry.
That wasn't me.
Oh, who was it? Oh, Alex. Okay, Alex. Yeah, Alex is good at chemistry. Alex is good at chemistry. Geometry. Sorry. Yeah, it's not. It's not a triangle plus rectangle. It's a trapezoid. Now the reason why I'm going over this one, why is a trapezoid important? Because in calculus approximation, there's something called trapezoid rule. So you need to know the area of trapezoid. How many of you guys know how to find the area of trapezoid? No, geometry have failed everybody.
You split everything into a triangle and rectangle.
Please don't tell me to. I'm so sick of.
Okay. 5 times parentheses base 1 plus base 2 over 2 close parentheses.
Yeah. Good job. How do you have that note?
Because when we did the how is it called?
Yes,
Yeah,
related rate.
rate.
Related rate. Oh, thank you. At least he knows where to look for. That's good. At least I talk about trapezoid. Okay, so I'm not crazy. I know I have talked about it, and nobody just know it. Oh yeah. What do you call something with nobody and no nose?
Nobody knows.
Sorry, I just want to. I like dad jokes. They are funny. I will watch those like real all the time. The dad jokes real. Huh? Do I have another one? What did What did the Obi-Wan Kenobi tell Skywalker when he go into when the Skywalker walk in a Chinese restaurant? No, it's not racist.
What?
Use the force.
Huh?
No man,
See, we're not up to top.
no man. Forget it. Maybe I got a joke wrong.
You're too advanced for it.
Use the force.
Okay.
Use the fork. The fork. Get it? All right. Anyway, so from one, if you want to figure out how high the one is, you can actually plug in, right? You can plug in here, and you know that 1 times 3 is 3. 3 plus 2 is 5. So you know that this here is 5. Is that okay? And you can plug in 4. 4 times 3 is 12. 12 plus, sorry, 4 times 3 is what? 12. 12 plus is 14, so it's going to be 14 here. And so this is a trapezoid. It's not a rectangle plus, it's not a rectangle plus a triangle. The reason why is they don't, you have to use trapezoid rule. The trapezoid rule, basically, this is the parallel line. So this is going to be the base 1 and this is the base 2. We already know the base 1, base 2. So it's going to be 5 plus 14 divided by 2 times the height. Height is the difference between 1 and 4. So it's 3. So it's times 3. So roughly that's equal to 19 over 2 times 3. So that's equal to 57 over 2. Yes. Because that's a good question. Why is over 2? Is average or 2 base? Do you see this length here that is here? And this length is right here, right? So if I take a 14 and 5 and average them, 14 plus 5 is 19. 19 divided by 2 is 9.5. So 9.5 is roughly right here. 9.5 is roughly right here. So if I have 9.5 is the height, right? So this is called average height, average base. Now, why is average base important? Because you can take this triangle, fit it right here, and it becomes a rectangle. So it's still base times height. Does that make sense? Yes, madam? Yes, the trapezoid area is base 1 plus base 2 divided by 2 times the height. And this is the area of trapezoid.
You still give us a point on the test for use triangle plus rectangle.
Yes. Because later on there's something called trapezoid rule. Then you have to do like 5 trapezoids rather than just 1. So you don't want to do 5 triangle plus 5 rectangle. That's too much work. Okay. Brian, call Max. Tell him to wake his ass up. Yeah. Fine, I'll call Max. I'm only teacher will call people to wake them up. Let's see if I call Max, he'll pick it up. Max. There we go. Oh, I should text his dad. Here, let me text his dad, it'd be easier. I have his dad's number.
O sea, esto es porque lo tienes que ver.
All right. Now, with the same logic, is you know it's area under the curve. Now, I'm gonna give you a brand new questions. So, the brand new question is gonna look like this. This one's gonna be a fun one. Absolute value x minus 4 between 7 to -2. So, how do you find integration of x minus 4 between, oh, sorry, it's -2 to 7, my fault. -2 to 7. That was a big difference. So geometrically understanding is more important because arithmetic to do this problem is going to take way longer than geometric understanding. So how do you take an integration between -2 to 7, absolute value x minus 4 dx? If you understand area under the curve, anytime you deal with absolute value, always graph it. Knowing how to graph absolute value is very, very important. You don't know how to graph absolute value. I hear that. I'm gonna call Samuel. Maybe Samuel know how to graph absolute value. Here, let me text Samuel. I'll be like, Emilia doesn't know how to graphs. Can you make a YouTube video? Can you make a short?
Because I forgot X's. You look a little lost.
So knowing how to graph is very, very important. Aiden, did you finish your rotation question?
I got that one, so it's wrong. I'm trying to figure out what it is.
Wait, do you know it's a disc or washer?
That's not pretty sure, right?
Yeah. Do you know it's dx or dy?
You want.
Do you know what your r of y is? Y squared plus 2.
That's y square root of x minus 2, right?
No. So it's the distance from the axis rotation to the function. Think about what that is. Okay, how many of you guys found it? Oh, that's good. Alex found it too? Okay. You can check, if you find it, you can check on Desmos. Just do integration, int, and just do, they will come out integration button, and you do absolute value of x minus 4 dx, and you can check if it's right or wrong.
What do we do for integration?
Int, just type in int. But you have to put parenthesis of, oh, actually you don't need to put parenthesis in this case. Usually you do, but this case is absolute value, so it is a group function already. So you can actually do it on Desmos. However, on a test, you're not gonna have Desmos. You're gonna have to evaluate this by geometrical understanding. So what I'm gonna do is I'm actually gonna show you how to graph this. If you have a hard time, you just set x minus 4 equal to 0. Why you do that? Because you know where the x-intercept is. So x equal to 4. So what you're gonna do is you're gonna go 4. You're gonna go to 4 right here, and then you're gonna have, guys, if you guys have set x minus 4 equal to 0, you will find out where the sharp turn is. And that sharp turn is gonna going this way. Because the slope is 1, so sharp turn is gonna go this way. And this one's gonna go the other way. Now what you're gonna see is, you're gonna see at 7, you're gonna see there is a 2 type of triangle here. So the base here is 3 and the height is 3, I think. So how do I what? How do I get the 3? Is the difference between, I count them. So this is a 4 to 7, so it's 3. And the slope is 3. And also, how do I know the what height is 3, guys? How do I know height is 3? You can plug in 7 in here. 7 minus 4 is what? 3. Absolute value 3 is 3, right? You can do the same thing on here. How do I know this is 5? I can plug in negative, or 6 actually. You can plug in negative 2 minus 4. It's going to give you negative 6. And absolute value negative 6 is equal to positive 6. So you can actually plug in negative 2 here. So it will be negative 2 minus 4. And that's going to be negative 6. Absolute value negative 6 is going to be 6. So you know this is 6. And this here is 6 also. So it'll be 6 times 6 divided by 2. That's the area of triangle. So area of triangle is 6 times 6 over 2. That's one of them. And it's 3 times 3 over 2. So that's equal to 36 over 2. That's equal to 9 over 2. So that's equal to 45 over 2 total. And I know that this one is 45 over 2. How do I check on decimals? You can go to decimals and just type in int here. That way you can know how to use integral. So they will say from here to here, which is from negative 2 to 7, and we're gonna say it's absolute value. Sorry, absolute value of x minus 4. But you have to put dx here. You have to put dx here to find out the solution. It's 22.5, which is also equal to 45 over 2. You can actually convert the fractions like this. 45 over 2, you're gonna get the same answer. Now that's how you check your answer on decimals. Does that make sense? Find out where the x-intercept is, then you can see the difference between x-intercept and the endpoint. You can evaluate this type of integral pretty easily. You can find out the height of a triangle by plugging the endpoint, and you can evaluate the height. Okay, so with that same question, can you find out what's integration between negative 1 to, that just says negative 1 to 6 of 2x minus 1 absolute value dx. And if you think you got it right, you can check your answer. Finding where the sharp turn is pretty important. Now let's just show you how to graph absolute value. Now the slope is 2, by the way, because this is 2x. So those are the things that you can find out by looking at the basic stuff. So a lot of those basic things you should learn in, let's say, in algebra 2 or in pre-calculus. And Amelia is supposed to know how to graph absolute value because we talked about it last year. Stefano, are you doing this? Oh, okay. Aiden? So if you have something like this, right? It's going from here to here, and it's rotating here. So you draw from the axis rotation, which is from here to here, and that is the dy. And so this is dy, right? And you know it's a disk because only have one line. There's no carve out. Now what happened is, in order to get this distance, you have to understand that the function y equal to square root x minus 2, you have to change in terms of x equal to. So be y squared equal to x minus 2. Is that okay? So y squared plus 2. But the y squared plus 2 is right here. This is a y squared plus 2. Okay?
Is it 2 plus that function or is it 2 minus that function?
No, it's actually neither. So then you have a black line here, right? And so what you can do is take the whole thing minus the black line. Then you will get a red line. Because a function is only from the axis to the thing. Like, so for example, y is equal to 1, so be 1 squared plus 2, so it's 3. So this distance is 3 units, just like what we see on the graph. Right? And then, so therefore, it's going to be 6 minus, so r of y is going to be 6 minus y squared plus 2. And you have to have a parenthesis there, because it's going to distribute. So it's actually end up to be 4 minus y squared. So it'll be integration of between 0 to 2, because the boundaries start at 0. This is 2. And then the disk is going to be 4 minus y squared dy. And don't forget the pi. And that's my final answer. Does that make sense or no?
Yeah. I forgot that my boundary works. It was still an x.
Yeah, you have to worry about a boundary as well. You want to try again?
Oh, yeah. That's
Okay, did you guys get an answer? Is it right or no? Everybody says no? Samantha, did you get it? You don't get it? First, figure out what a turning point is. The turning point is at where? 1/2. Good. You start 1/2. You draw like here. And then it's going to be 1/2. So 1/2 is right here, right? Now, we know that some type of slope is probably slope of 2 because of 2x minus 1. So that's going to be slope of 2. So it's actually going to be like something like this. But we don't know how high is it. How do we know how high? We can plug in 6 into here. So 6 times 2 minus 1 is what? 11. So we know that it's going to be 11. So at 6, this is going to be 11. So we know it's like something like this. You can write down 11 here to find out the height. And also I hear -1. It's going to be how high? 3. So we know this is 3. This is 11. Is that okay? And this is the difference between 1/2 to 6 is roughly 5.5 or 11 over 2. Is that okay? And then from here to here is what? 3 over 2. Yeah, so it will be area of this is going to be 3 over 2 times 3 divided by 2, which is times half, plus 11 over 2 times 11 times 1/2. So that's going to be 9/4 plus 121/4. That's equal to 130/4, which is 65/2, which is definitely 32.5. Is that okay? So you can find out this. Okay, those are special cases where you have absolute value. If you were to do algebraically for this question, it's gonna take way longer than this calculation, and there's gonna be not precise. You're gonna make a lot of error. More likely, 80% of chance you get it wrong because it's probably simple addition, subtraction of fractions. But here, this is actually have a lot higher percentage to get a right answer and much shorter time spent. Is this okay or no? Do you guys understand? Okay. Now comes down to this one. Now, so first thing you have to understand, what does square root of 4 minus x squared graph look like? If anybody know, let me know. You know what does 4 minus x squared look like? Huh?
Does it look like that?
No. Completely no. What does that graph look like?
It should have an endpoint somewhere, right? Because you can't take the square root of, you can't take the square root of negative numbers, right?
You are absolutely right. There's a domain. Just like the test question I give you on the graphic.
On the x-intercepts 2 and -2.
Anybody know what a graph look like? Can tell me? If you don't know, you want to graph on Desmo and tell me what it look like? Good. A semicircle. But how do I know a semicircle without decimals? Right? How do I know that? Because technically, this is equal to y, right? So y equal to square root of 4 minus x squared. Then you can square both sides. That's going to be y squared equal to 4 minus x squared. And if I move x squared to the other side, it'll be x squared plus y squared equal to 4. So that tells me that this is a circle equation. If this on SAT, this x squared and y squared present at the same time, and especially there's a plus between them, this is a circle with radius of 2, because this is radius, this is r squared. So r must be equal to 2. Does that make sense? So therefore, you can go back and solve for this, solve for y again. But why do I do the same thing over again? Because you're going to see something. Y is equal to 4 minus x squared. Now, it turns out there was a plus and there's a negative, right? Because you square both sides. So if you square both sides, that if I have a plus and if I have negative, so a plus is going to be here. And negative is going to be here. So this one is a plus square root of 4 minus x squared. This one is a negative square root of 4 minus x squared. Now you say, oh, okay, well, that's just a semicircle with a radius of what? radius 2, but semicircle area is 1/2 pi r squared. Why is 1/2? Because a half a circle. Pi r squared is something you know, right? And it's equal to 1/2 pi times 2 squared, which is equal to 2 pi. So the answer is 2 pi. Yes. Because it did not say negative. Because a plus minus make a whole. Like because you square root both sides, you should get plus minus all the time, right? So that should make a whole circle. But the thing is, this function is only asks you the positive part, which is the top part of the circle, not the bottom part of the circle.
Imaginary, the bottom one.
It's not imaginary, it's fun. Yeah, if you graph negative square root 4 minus x squared on Desmos, it's gonna come up bottom part of the circle. Got it? Okay. Uh-huh. How do I get what? Because this the circle equation is x squared plus y squared equal to r squared, and r is 2. So if you ever see on SAT, if you have x squared and y squared, the other side, the number on the other side, after you complete the square, is your radius. There's a lot of SAT questions like that, but it's that now the SAT you can just pretty much graph it on Desmos, and they will tell you can tell the radius too. A long time ago, when not digital, those questions presented, you have to complete the square. And which is, that makes it a little bit harder. Now you just have to graph on Desmo, you can tell from this. You can draw a line there, you can see that what the radius is. Okay, so what will be the situation from -5 to 0 of 25 minus x squared? Max says I'm on the way at 8:08.
Thank you, sir. It's concert day, so that's why I'm sick.
Oh, you're all over it.
And I'm all out of tissues.
After I solve this, you have a problem.
Yeah, so the same problem, I want you to rotate around y equal to 5. Y equal to 5. Sydney, can you get a door for?
Yeah.
That's what's supposed to be generally, yeah.
I told you guys to show up on the block day, make sure we cover a lot of stuff.
If there's nothing outside of the square root, that's
Are you okay?
So how is the
All right. And if you pay cautiously that this one is not a semicircle, the graph is a semicircle, but the restriction makes them a quarter circle. Does that make sense? So you have to be cautious on the restriction because yes, the graph is something like this. The graph something like this, 5, -5, and this is 5. So the graph looks like something like this. However, the restriction is going from -5 to 0. So therefore, it's only this that I'm going to count for. So therefore, the radius is 5, according to square root of 25. It's a 5. So it's a pi r squared times 1/4. Why is 1/4? It's a quarter circle rather than a half circle. So it'd be 1/4 pi times 5 squared. So that's going to be 25 pi over 4. So the answer is 25 pi over 4. Are we good?
Wait, where does it say there's a restriction?
It's -5 to 0.
Oh, it's literally just up.
Yeah, so you stop taking integral after 0. You stop at 0, so it makes, instead of semicircle, it's a half because you only integrate from one point to the other point. So I can adjust the shape by doing that. Does that make sense?
Oh, that's easier.
I think that's just weird.
Josephine, okay? You sound horrible.
We should.
All right, so does this make sense? Okay, so I can ask you a lot of questions like this, and you can figure out like geometric understanding.
Yes.
So after this, we would like to talk about a couple properties. And the property is, so this question is the absolute value one and the line one, because the line one you can do it arithmetically. So there was two type of way to approach it. You can actually plug in number to solve it, but the semicircle you cannot. The semicircle I have seen like one of the strongest students for the last 2 years would be there's a kid named Emmett Bradford. Emmett come to my room, says, "Oh yeah, he's taken with Mr. Cooper with double block, and he finished it, like he's always had like 100% on a Cooper's test." So when he come to my room, he's like, I try to recruit him for the math team, and I give him the same question as this one, and he had a hard time. And the reason why he had a hard time is he tried to do this question arithmetically. He's really smart, by the way. He eventually figured out it takes him 20 minutes to really figure out what's going on. Like he doesn't need some complex BC calculus to solve this problem. You can just understand visually, geometrically understand to figure out the graph is, and then to figure out the areas. But he's really smart. He was able to figure out on his own, but it takes like 20 minutes. Because the first thing we should look at the function like this, we should look at are they geometrically understanding. So we're gonna talk about some more geometric understanding because we're gonna discuss some properties of definite integrals. And here's the property. The property of definite integral the first one is going to be integration from a, which is a constant a, of f of x dx is equal to 0. Because there is no area underneath, right? Because we went from 2 to 2, there's nothing underneath the area. And that's very easy to understand. It doesn't require a lot of high-level mathematics. However, this one is actually pretty special because we're going to use that a little bit later. What if you have b to a of f of x? and we says we don't like B to A, and we want to switch the boundary around. So we can switch the boundary from A to B of f of x dx. Now we just had to put a negative sign in front of it. So you can switch the boundary to the favorable situation, which is preferred to be more negative on the bottom to the more positive on the top. Okay, so you can switch that so you can figure out those area under the curve situation. So then you say, okay, well, this is a very useful. I can change your boundary. Great. There is another one that I forgot to mention on other classes, but it's A to B of f of x dx. And this one is, it looks like this. Assume that this graph is something like this, right? And this is A to B, right? Now, what if I have a C right in the middle? So what's integration of A to B is going to be? Including the C, right? Can I just say, well, there's this area plus this area. Does that make sense? Can I just say integration from A to C of f of x plus integration from C to B of f of x dx? Can I split up to two partitions, right? Can I split up to two partitions and just add them together? Absolutely. This is a wonder property that you're supposed to know. So this is the third property. The fourth property, just like any constant multiple rule, so from A to B of k f of x dx, that's equal to k integration of f of x dx. This does work with the indefinite integral anyway. So you can take the constant outside of integral and you can multiply whatever the area is and just multiply the whatever constant at the end. This one's okay. This one's okay. Another one that you can understand is integration of A to B of f of x plus minus g of x and dx. You can split up two different integral, just like before. And this is a very useful, what we're gonna use later. So all these properties are super useful. From the A to A of f of x dx is equal to 0. From B to A of f of x, I can switch the boundary. I just put a negative sign in front of it. Very useful for me solving the problem. Remember, I prefer to be more negative on a lower bound to more positive on a higher bound. The reason why is we're gonna deal with that later. Is this okay? So let me 1, 2, 3, 4. The fourth is you can take a constant outside the integral. And the fifth one is sum and difference. Yes. Yeah. So right now is you can take a picture of the picture I'm about to draw. Because you don't have to draw it, you can look it back at the picture. So every period's picture is different. So it's already probably posted on it, but every period's picture is kind of different. So we're gonna establish this graph, and you don't have to draw it. If you want to draw it, you can draw it, but you don't have to draw it. You can look at the function and you can draw it afterwards. So that just say I have something like this and like this and like this and this and this and here I have a quarter circle curve. Like this. Have another quarter circle curve but going this way. And something like this. So I just draw this function. I make it a function kind of hard. We're gonna call this f of x. You can take a picture of this and you can answer all the questions. I'll even give you some numbers. So that's gonna be -3, -6, -10, -7. So I'll give you some turning point, -5, -1, 2, 4, 6, 8, and here's 10. So I'll even give you some number too. What is it?
11.
11. Thank you. Let me double make sure. Okay, yeah. So I'm gonna you guys can take a picture of this and then we're gonna answer you. I'm gonna ask you a lot of questions. So I'm gonna ask this question a lot. So A, what's the integration from -10 to -7 of f of x dx? So a lot of time AP exam just give you an image. They say, hey, can you tell me integral? And that just means you're looking for the areas. That's it. From -10 to -7. This one should be pretty easy. I can tell you it's not a rectangle and triangle. Also, you can take a picture of it, so instead of drawing it, you take a picture and then serve. Okay. So, what'd you guys get? What? 9. That's pretty easy, right? It's just a trapezoid. So it'd be 2 plus 4 divided by 2, which is 3, and then 3 times 3 is equal to 9. So yeah, you can look at a rectangle plus triangle, it's fine, but I just want you to know you have a formula for a trapezoid, but you had to memorize for later called trapezoid rule. Now I am gonna go to the second question, B. I say, how about the same thing? -10 to 7 of f of x plus 2 dx. Oh, actually, -10 to -7, sorry. So from f of x plus 2.
see negative 7. Oh, yes. I mean, you are, but you're not. No, negative 10 or more. So the bases are both, the bases are 2 and 4. So you add them together and you divide by 2. The height's going to be 3 because it's from negative 10 to negative 6. Negative 10 plus 2 is from negative 6. It's going to be 2 plus 4 over 2 times negative 6. Which would give you
So there's definitely two ways to approach this. For this question, you guys doing okay on this one? What do you think the answer is, Kimberly? 15? Did anybody get 15? 15 is good. Good job. Yeah, if you figure out 15, that's good. There was two ways to look at this. Why there was a two-way? Because you can think about this graph go up by 2. And that's one way to look at it. I don't like that way, but it's fine. You can look at this graph go up by 2. And sorry, go up by 2 like this. And you can figure out this area here. Right? That's one way to do it. So if I figure out the area of this, it's gonna be this is 12 from here to here, and this is 3, so it's gonna be 15. So you can figure out 15 here. However, I'm gonna tell you it's probably better to split them up. It's probably better to split them up for different reasons though, because later I can ask you a question that is require you to split them up. But if we go up by 2, that's another way to look at it. Visually understanding, that's just a vertical translation. So what I will probably prefer to look at is split them up between negative 10 to negative 7 of f of x plus integration from negative 10 to negative 7 of 2 dx. Why is that is good? Because this one you can say, well, this is just 9. And this is just a horizontal line of 2. Yes. Zoom in here. Okay. It's negative 10 to negative 7 of 2. So that means the height of 2 and the width is going to be 3. So that's going to be 6. Right? So that is going to give you 15 regardless. Yes. Yes. What? Where did I get 3? What do you mean 3?
You said 2 times.
Oh, because the negative 10 to negative 7, the difference 3. And 3 is a rectangle, right? We say y equal to 2. Then it's between negative 10 to negative 7. So that's how you get 3. So 3 times 2 is 6. How I get A? A is just this. So it's a 6 units here because 6 boxes. And this is 6 divided by 2. There's 3 boxes. So, or the area triangle. 3 times 2 times half was 3. Everybody understand or no? Nola, do you understand? Is this okay? Okay. Now I'm going to ask you different questions now. I'm going to ask you, hey, what happened if you have C? I can ask you, what is the integration between negative 6 to negative 3 of f of x dx? Now this one's interesting because I kind of mentioned it earlier. What happened if the graph is below x-axis? Even though you probably think about area as positive, but if they're below the x-axis, it's going to create different value. Instead of thinking about it, the areas, it's going to be values. Or Brian, is your condition?
Okay.
So -6 to -3 of f of x dx, what would it be? So now you see the graph is a below x-axis, and the orientations from negative to positive. And in terms of this, it's not just looking at area. Since they're below x-axis, that is gonna give you a, there's no such a thing as a negative area, but it does give you a negative value as far as the integral goes, because they are below x-axis. So in this case, if just think about this as a positive, right? But this has to be opposite of that. And so it has to be negative. You're going from the correct orientation, which is from low to high. From low to high, in this case, because from -6 to -3 is the correct orientation, so therefore it's going to be -3. And because they are below x-axis. So below x-axis and from low to high. Low to high. What I mean by low to high is -6 to -3. If from -3 to -6 is completely different, by the way, but then we're gonna deal with it later. Okay. Yes.
Okay, so the -3 is not from the difference between
-3 is right here because they're below x-axis. So it's gonna be 3 times 2 times half, because area triangle 3 times 2 times half. Huh? I cannot hear you. You gotta speak up. Yes. So you want me to write it down for you? Area of triangle is equal to 1/2 base times height. Yes. Yes. Cameron, you're gonna open the door this time because Brian's working too hard. You need a condition too.
Oh, I know a solution.
Yeah, Max is late. Max is late.
I got a freaking chair in my way.
All right, D. What would D will ask you is D? I will probably ask you says, okay, would it be between -7 to -3 of f of x dx? So there was some. What time we get off here, by the way? Aiden, you got it?
EX, I know that.
Okay.
Is it a disk? Because it's just a function.
It's a washer.
Why? Because you have to go back.
What happened? It's broken?
No, this one's fine.
Can you pop back in? All right, so what'd you guys get? -2? Yes. So it's a -2 because this part and this part, they offset each other, right? This is a +1, this is -1, so they'll go to 0. Is that okay? But there's another area here is -2 because they're below x-axis. So you can break up to two parts. You can break up from -7 to -6, which is +1. -6 to -5 is -1. And then you go in from -5 to -3 is going to be below x-axis. That's why you get -2. And that's how you get -2. Okay, I'm gonna say this again. Some people are looking like I'm going crazy. So this is a +1, right? And this is a -1, right? So can this and cancel this part to get 0? But then you have this part left, which is gonna be below x-axis, so it's -2. But remember, the orientation is very important. It has to be low to high. If it's high to low, it's different. So I'm gonna ask you the next one is a little bit different. So E, pay attention to orientation. Yes. Like this.
Can you not?
Because this one is positive. This one here is negative. Or you can do this one is +1 and here is -3. So it'll be -2 eventually.
And is that the one in the -3? Between the differences between like -7 and -6. Where are you getting the 1 from?
1 is a positive because this one is 2, 1. So it's 2 times 1 times half is equal to 1. Or we can think about it's a half of 2 because it's split diagonally. Are you sure?
Yeah.
Okay. So what about this one? Be careful of the orientation though. What about 0 to -3? So what do we say the boundary should be prefer to be in a correct orientation? So how do I change this?
Swap the 0 to -3 and then make the entire expression negative.
Yeah. So we know the property, we can switch this from -3 to 0 because when we look at area, it's always from left to right. But right now it's right to left. Then you say, well, I can switch that. It's not a problem. If I switch that, I will have -3 to 0. Now I can figure out the area. Well, we know the area here is going to be 1 and this 2. So 1, 2, 3. So it's going to be 3. So it end up to be -3.
Does it matter that Joe feels?
Huh?
Does it matter that it
It's over x-axis, but you put a negative. You have to change your boundary. You have to accrue your area from left to right. Because there was a negative sign in the front, we change the boundary first. So even though the area is positive, right? What just happened, Kimberly?
Like trying to separate it, like,
By 2 is just 1.
oh, because it's a trap. Because I'm trying to split it in half, where it's from negative 3 to negative 1 and then divide it. Well, I. Okay, never mind.
Are we doing okay? What do you mean not really? Look. Okay, so basically, do you see the boundary is off? It's not left to right, it's right to left. So you switch that from right to left. You put a negative sign in front of it. So this part here, just looking at the area here. So from here is 1, right? This is also equal to 1. And this is also equal to 1. So total 3. So it'll be negative 3. Or you can look at a trapezoid if you want. Okay, F will be integration between 0 to 2. Now this one's gonna be kind of tricky. F of x plus 2x dx.
The curve is supposed to be like a semi, like fourth of a circle, right?
Yeah, that's a quarter circle curve. It's a quarter circle. It's a quarter. Quarter of pizza. Wait, we get off at 9:06?
0 and 3.
Waiting.
F of what?
2x. Using all the property you learn. All right, so anybody got a value? No? So that's why I say it's easy to break down to individual pieces. 0 to 2 of f of x. Is that okay? Integration of 0 to 2 of 2x dx, yes. No, there's something to do with pi.
Oh, it's inside.
No.
You're just guessing.
No.
Keep saying them together.
That's right.
Could be. Hold on a second. For I think it's right. 10 plus pi, you say?
Huh?
I don't know.
Wait. Yeah, that's why I said this. Yeah, you're right.
You say 10 pi first.
Yeah, I said 10 plus 5.
Okay. So this is a 6, right?
Yeah.
And this is a pi, right? Because it's quarter circle. So first of all, this is 6 plus 5. Is that okay? And then plus from 0 to 2. Well, 0 to 2 it looks like this. 2x looks like that. Right? So this is 2 times 4. 2 times 4 times half, so it's 4. So it's going to be 10 plus pi.
Because it's like
Okay, the from how about from 6 to 4 of 6 to 4 of f of x dx. So 6 to 4 is a little bit more difficult to understand geometrically, but it should be fine. I know I'm gonna run out of time, so I'm gonna do one more. H. It's gonna be integration from 6 to 11, absolute value of f of x dx.
Do you have any scissors?
No.
None.
Somewhere over there.
I have a question also. How did the semicircle was defined?
Okay, so this is radius of 2, right? So 2 squared is pi r squared, right? For the whole circle, but it's a quarter circle. So this is going to be pi times 4 over 4. So cancel out, this is a pi. Look at over there, says there's the zero.
Here?
No, on the table over there. Huh?
What?
Somewhere, I don't know. So, shh. All right, I'm gonna talk about this really fast. From 4 to 6 is right here. But this is a pi, right?
Yeah.
So it's actually 6 minus pi. So, but the problem is this one's a 4 to 6 and it's negative. So it's equal to negative of 6 minus pi. So it's actually pi minus 6. Okay, for the last one, absolute value. Absolute value of this graph is going to make this part go back up. Because the negative region of absolute value is going to invert across x-axis. So this will end up to be 3 over 2 plus here is going to be 4 and 3, so it's going to be 6. So it's going to be 7.5. Bye. Bye. Good day.
I just forgot I have to throw it out.
You okay? You had a food poison?
Oh, because they made it negative.
I did.
Why is it even 6 minus? Why is it 6 minus pi in the first?
How was it? It was bad.
It was awful. Yeah.
So wouldn't it just be like a 2 and then like
It was like, cause my aunt, she went to a Thanksgiving party, she brought like food home. Like, there's like a bunch of us in the house and she brought like the leftover enemies. Alright, bye, Mr. Yeh. See you.
Bye. So this graph actually go in like this.
is there homework today?
Yes.
Okay.
It will actually invert it. Because you absolute value something, you take out the negative, you invert it above x-axis.
I'm confused on the pi part.
Okay, pi part. Okay, so you know that this is the area, right?
Yeah.
That this is what we're looking for, but we don't know. We know this is pi, so it's much easier to look at this whole thing, subtract the quarter circle. So you get this area right here. Because you take the rectangle, subtract the quarter circle, is easier. So those are like a geometry, like a lot of you guys didn't work on too much, but it's something that yeah we're gonna work. We're gonna have to deal with a lot, but in geometry we used to have to do this. I will ask students to figure out, okay, find out the area of this, right? But the thing is, actually, you look at the empty space, you don't look at the shaded region. So you take the square, you take away the quarter circle, you find the one empty space. You multiply by 2 and take away from a circle, you find the leaf area in between. Does that make sense?
Yeah, that makes sense. Thank you.
So